Okay, so we didn't really talk about this. I apologize. Rewrite the exponential expression to have the indicated base. Now, y'all did this whenever you had me. I called it base manipulation. So I need to write 1/8 as a base of probably 2. Oh, okay. Yes, if you go to the Google Classroom page, it says, tell her just go to Google Classroom and then right under the.
I'll text it to her.
Okay, thank you, Kirkland. So it says to make it a base of 2. So essentially, all I want to know is how can I change 1/8 to 2 to some power?
This makes more sense after I look.
Yeah, we looked at one of them.
I
do the rest of them.
Man, how?
All right, so then, all right, so negative exponent flips, right? And 2 to what power would give you 8? That's what I'm saying. 2 to what power would give you 8?
No, that gives you 1/8.
Wait,
And then I'm just going to flip it. I'm going to make it negative to flip it.
oh, okay, so making it negative just makes it.
Just flips it over. Yep, that's all it does. So I need to go back and incorporate this original exponent with it, right? Because that wasn't, it's not just 2 to the negative third. So it would be 2 to the negative 3 to the 2x. And now by my properties of exponents, I can multiply those two together. 2 to the negative 6x is the answer. That is rewritten. We still don't have Mary. Kirkland, did you text her the link? Thank you. All right, sure. Number 5. So 9 to the 2x with a base of 3. All right, don't tell him. So what can I raise 3 to make it be 9? What power? 2, right? So I rewrite this as 3 to the second power. That's the same thing as 9, so I haven't changed the value. And the 2x is still out there. So when I simplify it, it becomes 4x. That's what I said. Oh. He's doing 3 times 2. Domain, the asymptotes are horizontal asymptotes. They're all on the y-axis unless it's shifted up or down. I mean the x-axis unless they're shifted. Right? Because e to the x is a growth. So your asymptote, your parent function is going to have an asymptote here. Right? And it's going to be a growth. So, ooh. Y'all, it is really muggy in here, like sticky hot. It's like, I can't, we're not supposed to, but. So what I was saying is if what? So this is the parent function. That asymptote is on the x-axis. So unless you shift it up or down, the asymptote's going to stay the same. So the ones with the numbers on the end, like number 1, the asymptote would be, it's shifted up 3, so it'd be at positive 3 up there. Does that make sense? Corbin, you asked me about it. All right, so number 1, the equation is negative 2 to the x plus 3. Because of this plus 3, that shifts it up 3. So then the asymptote has shifted up 3 as well. Does that make sense? So your domain is all real numbers because it's not impacting the domain, it's impacting the range.
So the range would be.
Yeah, no vertical asymptotes in those. Logs have vertical asymptotes. Exponentials have horizontal.
So the range would be negative infinity to 3, but it'd be a parenthesis, would it be
Yes, it would be a parenthesis on both of them. Because this one, this negative is flipping it over, so it's gonna be,
so
Yeah.
those- that plus 3, those are as equals.
correct. What else?
Oh, yeah.
Oh, okay.
I didn't understand what it said.
I feel like, did we not do 20 in class together? That was on my notes to do together, did we not? Okay. All right, 19. So it says we have the population of Nevada for several years, and there are the years. Compute the ratios of the population in 1 year by the population in the previous year. So we are going to do the ratio of population in 1 year versus the other year. So 2168 over 2238. Every one of them. That's all you're doing. Oh. Okay. And you would do that each time.
So you literally just do that.
That's the ratio, right? And it's per year. Okay, so do y'all need me to do that? Can y'all handle that, dividing like that on your own? If you need me to. Speak now. No.
Wait, your answer would be that divided, or would it just be that?
That would be one of the ratios.
That's right.
Every ratio has to be.
Right.
So like 2000.
So you wouldn't have to divide, you wouldn't have to divide the funding.
So what you're essentially finding, think about that exponential equation, right? That's your basic exponential equation. What you're essentially finding with this is your b. And then what you can do is put your starting here. So what did you start with? We started with 2,168 times. What'd you get for your ratio? What's the,
I got 1.034.
The ratio is the same for all of you.
They're similar. They're similar.
so yeah, you'll just kind of estimate the best to, I'd take it out 2 decimal places, and then T would be your years since 2002. Does that make sense?
Yeah.
Mhm. So 2015 would be since 2002, what is that, 13 years? Plug in 13 for T. 3,000 what? There you go. That's when this is 15.
So that's the exponential.
That's your exponential, yeah.
Not 50.
13, sorry. Because it's 2015. Yes, that's your exponential. So, I mean, that's a very, very basic exponential. With no shifts, no anything like that, but that's all you had to do there. Does that make sense?
All right, so for 21 and 32, like, proof of problems.
Same.
I didn't know how to find.
Yeah.
Where it said what year will be over.
Yeah, it didn't give us.
Okay, that's where, so you had to solve it, right? That's where you need to solve by graphing.
See, I tried to
I
do
kept
that,
plugging in
but
numbers.
gigantic.
They are. They are.
Yeah.
Did you? That works too. I wanted you, I knew you didn't have the log information yet, so I wanted you to approach it from a different way. And graphing always works. Which one did you say?
All of them.
21? All of them. The population of Knoxville is 500,000 and is increasing at the rate. So I'm going to go ahead. This is my initial amount, right? 500,000. Mary made it. Hi, Mary. She's waving. By the way, we're going to have a quiz this week. I'm thinking Wednesday or Thursday, and I'm thinking like a Google form thing. So for my virtual people, you will have your camera on. This is the best way this is what I have decided to do with the test and stuff. I think I'm going to still do paper pencil test. Do y'all have a way to print stuff out? Okay. I think what I'll do is I'll let y'all print it. I'll send it to you at a certain time and have you print it. Your camera will be on your test, and I'll need to see both hands the whole time. Then you can't That's the way they did it whenever I did an online class and had to take a paper pencil test. So I think that'll be the easiest way. Well, but if I don't release the test until it's time to take the test, and then they have to,
Lay my notes out like.
But then you have to give
But-
them time to print it out.
yeah, I do.
Miss McKee, you should make
Yes.
23 after this.
What? Kirkland, what?
23 next.
What? Are you kidding me?
Hold on. For some reason, I can't hear you this morning. Hold on.
Yo, the reason like half of us are here.
Mary, I will let you know, and I'll let you know you're asynchronous, so it'll be a little different. I got to work out a little something differently for you, so I'll let you know. Kirkland, I will do 23. Let me finish 21, and we'll hit 23. Okay. 21. All right, so the population of Knoxville is 500,000, increasing at the rate of 3.75% each year. So this is going to be 1.0375, right? Because you got to add that one to it. It's growth.
See, I don't get where.
Okay, so if you think back, your growth formula, when you're talking in terms of anything other than money, it's 1 plus. Decay,
I thought it was 1 plus R over N.
that's for interest.
Wait, where is that?
Did we not do a basic growth formula?
No, we only did.
Okay, I'm sorry.
Like the notes, like I literally have like insane.
Clearly I failed on this. I'm sorry. I
We had
apologize.
like 2 minutes. Yeah, it was.
Okay. Nobody asked, y'all said this is confusing, I don't know what to do, but nobody said, Ms. McGee, what's the growth formula? What do we plug into?
I didn't even know what the growth formula.
I would or what equation do I use for number 21? And then I would have sent a reminder to everyone and said, oh yeah, by the way, I forgot to give you this formula, here you go.
Okay, so wait, let me go over.
Y'all have to be a little more specific. What, Kirkland?
Answer.
Okay, so this is the growth formula.
Hello, Kirkland, I know you're talking and I cannot hear what you're saying. Say it one more time, I've got my ear to the computer.
I use per and I got the right answer.
Pert will come dangerously close. The only thing with pert is because the E is an approximation for your, you use pert for 21? Y'all use pert for all of them? I am so sorry. It'll probably be close, but it's not going to be exactly right because the interest rate is not exactly right. That's when it's compounded continuously, but it still takes the rate and all into, it'll be close. It'll be close, but you don't want to do that on an open-ended calculus question, because then they're looking at the method that you use. All right, well, here's your growth. Did anyone remember these formulas from Algebra 2? Now you remember it. Okay, well, that would have made your life a whole lot easier. I'm going to put the T here. When will it equal 1 million? And so this is what several of you asked about, how do you solve these? If I'm solving these and I don't know how to use logs, because logs are the ideal method for solving unknown exponentials. That's what they do. Logs are exponents. But because we don't have that knowledge yet, what I would do is you can do one of two things. You can make the equation equal 0. So to do that, I would have 500,000, 1.0375 T minus a million. Then, when I graph it, please don't bog down. You'll cross your fingers a second. Is the lag any better this morning? I think he said yes. Yeah, I agree, but I think the lag might be worse on our part this morning than on their part. It's probably now going to just Drag. Are you cold? Yes. I am going to put this equation in 500,000 1.0375 x minus a million. What? No, because I don't have parentheses around it. All right, 1 million. That's 1, 2, 3. 1, 2, 3. Do I have the right number of zeros on my 500,000? I know. I'm thinking of what I need to take my x out to. Well, you're talking in terms of years.
69,000.
Never tell you what I got.
No, because I want to do this as if I don't have the answer. Ah, I found it. Okay. Whew. I took my x up to 100. I figured it wouldn't be any more than 100 years. So now, do y'all remember how to calculate a zero? Second, trace my zero. Where am I? I am way high. Nope, I'm not. No, Joseph, you put that in the wrong way. I need to come way over here. X is at 20. I should be crossing any time now. Did I cross?
Yeah. It just jumped.
Okay, I was looking at that line going, no. It's okay. As soon as it stops, I'll let it guess. Approximately 18.8 years. Is that what y'all got? Is that what you got with your logs, Corbin?
I guess 25.
That's what I got.
Yeah.
Instead of like graphing, what I just plug in the number in the machine, and then if it's like not close to mine, it's like go up.
That's
So you
exactly
went
what I
in,
did.
so did you go into like your table to do that?
No, I just type it in here and I start.
Oh, I see what you're saying.
Until I get to
That works too. That
That's
works
exactly
too.
what I did.
That's fine. Yeah.
What you did?
It's just going to be handy for you to know how to take any equation and solve it graphically, because that's always an option for you. If you get to any type of equation and you go, oh my gosh, I do not even know where to start with this, you can always make it equal 0. You can always graph it. You can always find where it crosses the x-axis. Always solution. That's the answer.
What did you do with your food?
With my what?
Like with your window? Because I tried to zoom it in.
Well, because if you zoom fit it, it's going to try to give you the whole curve. And you don't really need the whole curve. You only need where it's crossing the x-axis. So I had to think through the problem, and I thought, okay, I know I'm looking for x. X is never going to be negative, so I know I start at 0. Y is really irrelevant because I'm just looking for where it crosses. And I thought, okay, it's asking me after how many years will the population be a certain amount. I don't think that's going to be more than 100 years, so I took it out to 100. Maybe you took it out to 20, maybe you took it out to 50, maybe you took it out to 500. It doesn't matter. The point is just that you find where it crosses. All right, y'all okay on that now? All right, Kirkland, you still need 23? Yes. Okay, and somebody texted me yesterday or Saturday, and I texted them. Was that in here? Because I feel like I need to explain what the formula was. Was it with the N?
The other day, we traced on the board. I'll say no. But we have to do for enrichments.
Enrichment? Yeah. Yes.
What have you been in here twice?
Say again?
What's the point of you being in this meet twice?
One of them I have on a separate computer over here so that if y'all chat a question or anything, I can see it. Other one on my laptop that I'm writing on is recording the screen. Okay, I don't even see it.
Well, we need to bring these.
Well, you need to bring what? Not just yet. I'll let you know when you need to start bringing them. All right, so half-lives. So you do your initial amount. I'm just going to call it A. Okay. My decay factor, or how it's decreasing, is 50% each time, right? So 0.5. And then I raise it to the time divided by how much time is in this half-life. So how long it takes it to do a half-life. So for this one, the half-life is 14 days, right? So that's how long it takes. So that's going to be my 14. There are 6.6 grams initially. Is this how y'all did it in science?
It was like
T over T sub H. Oh, okay. Yeah, or the time of the half-life, whatever you want to. You can name it whatever you want. That's why I was trying to find what I sent them, so I'd use the same kind of terminology, but it's okay. Express the amount remaining as a function of time t. So this would be t over 14. And then for the second half, when will there be 1 gram remaining? And so now I'm back to the problem like what we just did, where I can set it equal to 0 and I can graph and find the intercepts. Y'all want me to do that real quick? Yes, Miss McKee, we would love for you to do that. Thank you, class. Did I not have to subtract 1 layer? What'd I do?
I didn't see you send those.
I did not. You're right. Wow. I couldn't figure. I was like, oh my gosh, what did I do wrong? There we go. Thank you. Thank you. Thank you. I didn't set it equal to 0. She's absolutely right. If I'd left it like that, I could have graphed the line y equals 1 and then found that intersection. But all right, second intersect, which is 5. I'm not still clicking that. It's doing that on its own. Not intersect. Zero, right? Are y'all with me? So I'm just like staring at this screen and there we go. About 38 days. Is that what y'all got?
Yeah.
Or if you didn't get that, do you agree with my mathematical reasoning here? All right, Annie says 25. These are going to start going a little bit quicker because they're all the same. How much time is required for an investment to double in value if interest is earned at the rate of 6.25% compounded annually? Compounded annually, you don't have to use, you actually don't, it's pretty nice. Let me put my R over N to the NT. If N is 1, because it's compounded annually, it's a basic growth formula is what it is. So it's 1 plus R to the T. So you have, oh, it doesn't say how much you have. Okay, well, let's just do an amount. Let's say you put $25 in. 1 plus 0.0625 to the T. When will that equal 50? Set it equal to 0, so move the 50 over and find the, y'all want me to do that?
I did 2T.
Oh, that works too. That works too. Yes. When it tells you that the interest is compounded a certain number of times per year. Huh?
What was this question?
How do you know, bless you, when to use the one with in and when to use pert?
Yeah, so wait, why don't we use, we wrote it, but why don't we use that? So
Because it said that it was compounded annually. Annually is one time per year.
The N is times per year.
So R divide, the N is how many times per year? So R divided by 1 is R, and 1 times T is T. What is pert? Mary, pert is whenever we compound continuously. If the problem says compound continuously, we use pert. P is your initial amount. R is your rate. T is your time. And E is, of course, that irrational button on your calculator. Does that make sense? And because it told us how many times per year it was compounded, I didn't use the other one. I used the one with the N in it. Okay. What was that? So 25 and then 22. 22. The population of Silver Run in the year 1890 was 6250. Assume the population increased at a rate of 2.75% per year. Estimate the population in 1915 and in 1940. So I need an equation, right? Basic growth. I'm going to let this be my starting point, so my T will be years after 1890. Initial amount, 1 plus R, so 1.0275. To the T, so here for part A for 1915, how many years past 1890 is that? So I will just plug that in. When you plug that in, what do you get? Somebody tell me something. Everybody get that? It didn't catch my, it's still not catching my, it's not catching my 5. So PERT is for compounded interest. Huh?
That one's for compounded, they're both for.
Continuously compounded interest.
And then the gross one is like 1.
Population growth is always basic growth, the easiest growth formula you have. Yes, this is, yes. Well, this is your A times 1 plus R to the T. That's growth. I know, that's what I said, I'm sorry. How about, what was the next year? 1940. 40 is how many years? Plug that in here for T again. What'd y'all get for that? 365? Is that what you said? 265. Everybody good? Virtual, y'all good? Yay. Same, Kirkland. I'm drinking coffee too. Couldn't get going this morning. Any other questions? (31) Cholera bacteria. Suppose that a colony of bacteria starts with 1 bacterium and doubles in number. I lost my place. Every half hour. What? What? All right, so this is kind of like a half-life problem, but the difference here is that when I come here to do my base or my rate, if it's doubling, what's the rate? Well, this time it's doubling instead. So 0.2 would be decreasing, right? It'd be 2.
Wait, it would be 4. Half hour.
Well, I'm going to take that half hour into account in my exponent up here. Remember, because I've got T over And then this is where I'm going to do a half because it's every half hour. Right?
Yeah.
So if it doubles, it's going up 100%, right? Pick 100% of the number, but I got to add that 1 to it. So it's 1 times 2 to the, actually it's going to be 2t. The reason it's 2t is if I divide by a half, that becomes 2t, right? Y'all follow me? So then it says how much at the end of 24 hours. So if you put a 24 in there, what do you have? I cannot breathe. No, this is so hot. Like my eyes are even getting like. I brought my. How do you tell something's a function, first of all? Vertical line test. What are you testing for when you do that? Exactly. And we touched on that a little bit on Friday and talked about how we look. We only want one specific y for every x value, right? If it's got 2 y's corresponding to 1 x, it fails of our triangles. It's not a function. Tell me what this means.
There's only one,
Y'all don't remember this?
Right, it's not like we're just trying to.
Okay, 1-to-1 means it is a function, and its inverse is also a function. Okay?
That sounds familiar.
Okay, so in Algebra 2, I told you to use the horizontal line test to check to see if its inverse was a function because remember, inverse switches x and y, right? So if you think about the x and the y axis switching, if you did that, then it would have to pass the vertical line test. But instead of inverting the axes, we'll just invert the line test and go from there. Does that make sense? Can you think of a 1-to-1 function? Y equals x is a 1-to-1, yes. How about the growth we've been doing? Right? The growth and decay, that's 1-to-1. Not a parabola. Yes.
So, the vertical line test, you switch it months. So, instead of doing the math, you do a 1-hour line test.
To check to see if it's 1-to-1. Yes. X cubed is 1-to-1. Yes, x cubed is 1. That parabola is not. So this is a function, but it's not 1-to-1. Does that make sense? Okay. Tell me, and I kind of just said this. Y'all got that? You need me to wait a second? Am I going too fast? Okay. Oh, Kirkland, that's smart. You mean suggest that to Miss Corner? That's smart. Suggest a virtual enrichment for students who only have 1 class, so if they choose to, they can join virtually instead of driving back and forth to the school.
Yeah, pretty much.
Well, would you rather waste your gas money and come back here?
Yo, enriching is stupid. It's like good.
Tell me how we algebraically find an inverse.
Plug in
Okay, what's f of negative x? We essentially are switching, not to negative.
Oh, no, we need y.
Yes. We switch x and y, and then we solve for y. Now, of course, The equations that we will be finding inverses of are a little more sophisticated than what they were when you first learned how to do this, which we did a lot of linears and quadratics. This is number 11. What?
X equals y plus c equals y.
Do what?
Switch to x and y. Use like first circle. And do x and y.
Let's do a log one. This is number 11 for, you won't do number 11, but I'm going to do this one because it closely follows some others that you have to do. Let's say f of x equals the natural log of x squared. Let's find the inverse. Let's find out if it has an inverse. Tell me first of all, I mean, we can go ahead and do this. Right? What is natural log? It's, somebody said e. It's a log with a base of e. That's the natural log. So this is essentially, now, I'm trying to solve for y. Why do I need to know that that's log base e? How am I gonna, you have to what? Okay, so how am I gonna get this solved for y? Do you remember?
You multiply by e. No, I already the exponential of log.
Do y'all remember? Change the form? What would this look like if you changed the form?
E to the x equals to y squared. And then you just square root.
Right. Hold the phone. Because everybody's kind of like staring at it, soaking it in right now.
So A consists of that number and that x number.
Yes. Okay, so if I said the inverse of f is this, would I be correct? I'm close. What might I be missing? Y'all hated me in Algebra 2 when I did this, and I took a point every single time.
Plus or minus?
Yes. You're right, the silence is kind of eerie. Every time I do something, everyone's like, I thought I'd never have to do that again.
So, what does eerie mean? I just said it, but
Yeah, like a creepy kind of.
Creepy. Like your outfit. Something. Your Halloween.
Okay. Do what?
Donna just put something on.
Donna just grabs the first thing he finds in the box.
Granted, I
Mine's always got colors.
Do you think,
Like a different shade of the rainbow, isn't it?
do you think that f of x is 1-to-1?
Wait,
I also
hold
something.
which is it, 1-to-1?
Is f of x 1-to-1? I know f of x is a function because it's defined as a function. It's f of x. Okay, Zach says no, no, no.
Why? I don't remember.
Let's graph it and see. Why fails the horizontal line test?
How would you tell that algebraic?
Oh, because if it's the inverse, you know.
Because, go ahead.
Just say if it's the inverse, you know the graph of one of the functions, flip it, right?
Yes, yes. You could flip it around. Algebraically, you have to think about it graphically, even if you don't graph it. Well, think about a square root graph. You know a square root graph, what it looks like, right? So if I do the plus and the minus of that, it's going to pick up the right. Yay or nay? Oh, y'all are going to love this next one. It's the last. Was that somebody knocking at the door? Oh. How do I do this?
Just grab it.
Algebraically prove.
Oh, man.
So here's what I'm gonna have you do. I'm gonna have you find the inverse and then prove the inverse.
Which is like,
That's not proving.
Would you just like
Plug it in and solve for something.
So
You're very close, not into itself,
we don't prove it by doing the horizontal line?
put a zero?
but we're gonna write it a little differently than what you did before.
Yeah.
Oh my gosh, all right. So I plug the inverse into the initial, and then I also have to do it this way. I compose it both ways. Remember, this is where it all cancels out down to x. But here, in Algebra 2, I always told you they are inverses. Just show me, so you knew that it was canceling. Got to go in the order of operations on this one. Okay? So, oh, sorry. All right, so let's do one. This is number 23 in your book. I'm hoping this helps you a little bit, that they're modeled after the problems. I'm doing like problems from there that models. That's what y'all are used to from pre-cal anyway, right?
Yeah.
That's 2x plus 1. Mary must have to go to work. Let's say I asked you to not only find the inverse, but prove the inverse here. Tell me what to do first. X and y. So x equals 2y plus 1 over y plus 3. Oh dear. What'd I do? Multiply by y plus 3. That's exactly right. So I get x times y plus 3. 2y plus 1. Distribute the x. Okay, so that's really loud. I'm solving for what? For y. That's right. I'm going to do some manipulating here. I'm going to move this over, and I'm going to move this over here. Does that confuse anybody if I do that all in one step? I do not. If I do it up here, you can do it. For sure. It's 2y equals, and I'm going to do 1 minus 3x. Am I going too fast? All right. What can I do now? Remember my goal is to get y by itself.
Subtract the y.
Factor out the y. Let's factor out the y. And then what? Divide by x minus 2. So I'm going to go ahead and write inverse. I'll switch this to negative 3x plus 1 so it's a nice, pretty standard form. You don't have to. Over x minus 2. Everybody okay on that? That's all for finding it. So that's one of the two parts. And then the second part also has two parts. So. Do y'all remember composition? Yes. We drilled that in Algebra 2, and I'm assuming you hit it in pre-cal as well.
I don't know, I blocked out the
Yeah.
Did that in homework?
All right, so I'm going to take the original equation, and I'm going to plug this in for the x's to start with. It's just going to be messy, that's it. Make sure you know the order to cancel things out, because if you get on the exam, they have people who are paid to look at every step of your work, and they have an infinite amount of time to do it. And so they're going to look and check and make sure these kind of little nuances here that you're doing it right. All right, so 2, it's not x anymore, it is negative 3x plus 1 over x minus 2. Yeah. Plus 1 over.
Oh, yeah.
Yeah, I'm using this original equation, so I'm.
Wait, where are the?
All right, take a look at it the way it's written. 2x plus 1, x plus 3. My x is the inverse.
Thanks for the fractions.
And then we follow order of operations. That's okay.
You insert the original into the.
That's right. Every time there was an x here, I replaced it with this. All right. Are y'all ready? Can I what now?
I thought you were just making it through by yourself.
See the poster? You can't cancel out if you're adding or subtracting. It's only when your operation there is multiplication straight across.
What if we don't let you?
You didn't have some sound.
Yes. All right, so if I were going through this one, what I would do is go ahead and distribute this 2 up top. It's only going to the top, right? I changed that 1 to have the common denominator. Y'all remember complex fractions, and I told you take it one piece at a time, and I had you draw 3 columns on your paper. Top, bottom, together, right? This is a complex fraction. Just the top. Because this is like over 1, and when you multiply fractions, top, top, bottom, bottom. You see what I'm talking about, though? How, I mean, this is so much algebra, and the concepts are not, that it's the algebra that comes back to bite you in the butt. Okay, so what I did, remember when we found LCDs, least common denominator? I just made it have the same denominator so that I can combine them. And I'm fixing to do the same thing here. I want this to have an x minus 2. So I'm going to have negative 3x plus 1 over x minus 2 plus, I'm going to go ahead and distribute that. Is everybody okay with that? 3x minus 6 Ready? I'm going to have to go to the next page. So somebody's going to have to, I'm going to go ahead and combine up top here. Actually, let me show you this. Do you notice how every single denominator is the same? Right? X minus 2. If I multiply the top and the bottom, think about this fraction as a whole right now by x minus 2. Now, if you went the long way about this, it's okay. You don't have to do this. I'm just showing you this because every single denominator is the same. Here, it would cancel. And here, it would cancel when you distribute through, right? Same thing here. My fraction suddenly looks a lot better, right? Okay. So I've got negative 6x plus 2. What else? Yeah, somebody read it to me because hold on. My computer's not going to let me go back and forth between pages here. I messed up. I accidentally hit go back and y'all continue working, that's fine. While my computer thinks about changing the page. Well, what happens is if it's in the top and the bottom, think about whenever we did simplifying rational fractions, it cancels out. The two factors cancel out. All right, what's the rest of my thing here plus x minus 2? And what's on the bottom? Those are gone. Up top I have negative 5x, yep, over 5, negative 5. Look at there. Can you believe that nastiness simplified down to x?
And we have to do it all over again?
Wait, what?
You have to plug it in the other way.
Oh.
That was f of the inverse of f. Now we have to do, yes.
So whenever you multiply by x minus 2 to cancel out the denominators,
Mhm.
that you just like pull that out and put times x minus 2 on the top bottom.
Yep. All right, let's go the other way with it. I'll be done. I told y'all this was the last example. I just didn't tell you how long this last example was. All right, so we got 1 minus 3x, but it's not x anymore, it's 2x plus 1 over x plus 3. Where's the what? 1 minus 3x. Right? Over x minus 2?
Oh, you got it. Hold up. See, I have.
Oh, I'm sorry. So negative 3 here. Negative 3 plus 1. Okay. Sorry. I'm following my notes where I wrote it out. All right, and then 2x plus 1 over x plus 3 minus 2. Not quite as bad as the last one. Still not, right? Still not great. No, I agree. I am going to go ahead and make this x plus 3 over x plus 3. Do what? And I'm going to do the same here. Because you silence again. All I'm doing is making common denominators here. So as I go through simplifying, it will be easier on me. All right. I'm going to go ahead. Let's look. Same scenario. Every fraction. I am going to multiply it out. I'm going to do that in the next step. Because this is 3 over 1 times this. I'm going to take it here, not there. All right, and all my denominators are gone. And I showed y in the last step. So we're good on that? You understand why? Okay. All right, so I got negative 6x minus 3 plus x plus 3 over 2x plus 1 minus x. Watch that sign here, minus 6. Now it's shooting up nicely. So I have negative 5x the 3's are gone over therefore have y'all seen this symbol before? It is the best symbol in mathematical language because it means I am done proving what I needed to prove, and therefore I can state that 2x is 1. This is kind of like that last line in a geometric proof where, oh God, I am here. 2x plus 1 over x plus 3 and 1 minus 3x over x minus 2 are indeed inverses of one another.
Are they gonna give us 2 things until
You don't have to write are indeed, but are. So